So this will be a quick explanation on why parabolas, if we have like, let's say, a mirror that's shaped like a parabola, so this is like the cross section, and if we have light rays from the sun coming down like this, we're just going to assume they're all straight, right? So these are the rays of sunlight. Why all of these, all of the light that's reflected off of the surface, why they all focus on one point. So basically why a parabolic mirror focuses all its reflections on this one single point right here. So first off, we have the equation for the parabola, y equals x squared, right? And then we want to basically find first the slope. We just want to find the slope or the tangent to this parabola. So we're just taking the derivative here, right? Y prime is equal to 2x. So these are just going to give you like all these tangential slopes. And the reason why I want to do that is because then after that I want to actually figure out the perpendicular slopes to the curve of the parabola. So all we want to then figure out after finding the tangent, right, the derivative of the parabola, we want to find the orthogonal. So it would be these angles. And the orthogonals would give us the angles of reflection, right? So at this point, we have the normal, the orthogonal, pointing. Well, it would be, in this case, we're just going to assume it's flat. It's going to be 90 degrees from the tangent of the parabola, right? So we have the slope of the parabola. And then we have these the reflection lines, not the reflections themselves, but the reflection lines, which are facing inward, right? Or it doesn't have to be facing inward, but these are basically these perpendicular lines to the tangent of the parabola. These just show you the axis of reflection, right? So whenever you have something that's being reflected, so like let's say we have this, if we have a mirror that's slanted at this angle, right, this middle section, the perpendicular line would give you the axis of reflection, right? So if the light comes in from here, it would bounce off there, right, across this axis of reflection. And that's all we're trying to figure out, this axis of reflection. So after we take the derivative, right, we just want to find the perpendicular line, right? And that would just be 1 divided by negative of the slope, right, which is 2x, right? So 1 divided by negative slope, and that's just the equation for the perpendicular, right? So if you have a if you have a slope of, like, let's say 2, right, the perpendicular line would have a slope of -1/2, right? It would always just have -1 divided by whatever the slope is of the other perpendicular. So all we're doing is just finding the perpendicular of the derivative, right? So now we have these axes of reflections, right? These axes that show you the reflection. And then now we actually want to find the angle, right? We want to find these angles of reflection. But since each angle would be different, the angle of reflection would be different for each area. So now we want to find theta, and we say that's equal to tangent inverse of 1 divided by slope. And to clarify, this slope is referring to the perpendicular slope, right? So the axis of reflection. So this part is what I'm referring to when I say slope. So the reason for this is because, like, let's say if we look at this graph, for example, right, and let's assume the mirror, right? The mirror is this, the axis of reflection is this, right? So that's the slope. We actually want to find this theta, right? So if we draw like a right triangle, we actually see that we have to, right? Usually when we have like a, when we have, if we find the tangent inverse of this slope, right? If we find the tangent inverse of slope, that would give us theta. But if we look at it, if we just kind of turn it around, right? Rotate this whole thing 90 degrees. So this would be the 90-degree angle. This would be theta. Or sorry, not that part. It would be, if you just rotate it around, we would have this. It's blurry. Yep. So we would have this as the 90-degree angle. This top part would be theta. And so actually, right, we, instead of doing rise divided by run, we have to do run divided by rise, right? We have to rotate it this way, right? And that would give us 1 divided by the slope, right? And so basically we're just, instead of rise over run, we're doing run over rise. And that's just because theta is rotated. So instead of it going from, theta is orient based, because we orient theta this way, because the light is coming in from the top, we just have to invert the slope, right? So that's all we're doing here, 1 divided by the slope. And then we're actually multiplying this angle, right, theta, by 2. And that's because with the reflection angle, right, we just have 1 and then 2, right? So we have the angle before the axis of reflection, and then we have the angle after the axis of reflection, right? So we're just multiplying, right? We're multiplying by 2, and that's what this is referring to, the angle of reflection. It's the total angle, right? It gives you the total angle. And then now we've got the reflection slope, right? So the reflection slope, now we're just taking 1 divided by tangent of theta reflection, right? So we're just inverting the slope again, right? And this time, right, tangent theta reflection gives you the slope, right? This slope right here, this slope. So this slope, so this slope. And we're just inverting it again. And that's because now we want to find the orientation for the reflection, or for the slope of the reflection. That's why. So once we do that, we can find, we can just plug it into, of course, the equation for lines, right? Just y equals mx plus b. And we can do just a couple of checks just to make sure this actually works. And so this basically just gives you, this actually gives you the slope of, this reflection slope gives you this slope, right? This slope right here, this slope right here, and this slope right here. And so if we look at this graph, right, if we go back to this graph, right, if we have these lines, right, these light rays, they hit the mirror, right? So there's some certain angle it hits the mirror at, and then it's going to reflect at that exact same angle, right, over the axis of reflection, right, over this axis. So all we're getting are these lines, right, these lines right here. And again, this reflection slope, right, reflection slope gives you the slope of these reflections, right, the slope of the actual reflections. That's what it gives you. And then if we plug it into y equals mx plus b, right, so if we have, like, let's say this point, right, which is x is equal to 2. So let me label this, right, x-axis and y-axis. So since we have x is equal to 2, yeah, we know y is equal to 4, right? So this is 2 comma 4, for example. And then here, all I'm doing is plugging in each of these specific points for the parabola, right? So x is equal to 2. Then we get a slope of -1/4, right? This is the reflection slope. And that's just by plugging in all the values right here, right, for the slope. And the slope, of course, is given by 1 divided by -2x, right? So plug in the value for here into the slope right here, and then find the angle and then reflection slope. And this value is the reflection slope, right? So it's this slope going downwards, right? The reflection. So if we plug that in, oh sorry, this 1.875, I made a mistake. This 1.875 is the reflection slope. The negative quarter is actually the slope right here. It's this slope, the axis of reflection slope. But the actual light beam, right, not the axis of reflection, but the slope of the actual light beam itself is 1.875. And then I just plugged in values for x equals -1, 1, -2, and so on, just to check that this works. So if we plug it in, right, y equals mx plus b, we know if x is equal to -1 or 1, y is going to be equal to 1, and then if 2 or -2, y is equal to 4. So we plug this whole thing in, and we don't have b, right? We just want to figure out b, and we know b gives us quarter for all of these points, right? All of these points gives us b equal to quarter. And then that means we know that all the light paths cross each other when x is equal to 0. What do I mean? Because it's a parabola, it's symmetric, right? It's symmetric across the y-axis, right? It's completely symmetric. So we know these light rays, right, they will always cross at 0, and that's because it's symmetric, right? It's it's just a reflection across the y-axis, right? This left half is exactly the same as the right half, right? So they'll meet in the middle, right? They will always meet in the middle, and that's just a very intuitive way of explaining it, which means if they cross each other at x equals 0, right? So if we plug x equals 0 back in, once we solve for b, we just get that y is equal to b, right? Which means b gives us the value for y, and since all of these are the same, they all cross at y is equal to quarter, x is equal to 0.